is syphilis. They never form the balls or tangles of spirochetes. They're always separate. Let's go back to Borrelia. Borrelia burgdorferi. Disease, Lyme disease. What's the vector? Deer tick. Some people say sea tick, some people say deer tick. That's not the dog tick, right? Tiny. You may never know that you were bitten, ever. Only in a small number of cases do you get through bullet-like rash. Doctors often, if they even suspect it, won't wait for antibodies to show up in your blood. They will give you antibiotics now before it establishes because they're worried about it. Now, if Lyme disease becomes symptomatic, the symptoms can be severe fatigue. It can also, emulate rheumatoid arthritis, a lot of pain. And yes, it can hide. It can hide in the cerebral spinal fluid. That means the fluid of the spine, fluid of the brain. It can also cross the placenta. And it can do damage to the fetus. We don't have the movie anymore because of the VHS and the machine ate it. Okay? I couldn't find the same movie anywhere else. But it shows some of the damage that's been done to children. Alright? Lyme disease is in Florida. The other one, syphilis, treponema pallidum, treponema. What? 3 stages. Primary, painless canker. Secondary, more serious, which is hiding Huntington in between. Third time, harms your heart, is going through the brain. This is primary, secondary, tertiary syphilis. And yes, it's an STD.
What happens during the second phase?
I'm sorry?
What happens during the second phase?
It's just a general attack, but it's more serious than the first time. Third time is the one you want to reach. The thing with symptoms is you've got to do a lot of, everything can give a fever almost. Everything can make you feel ill. You got to tease out what's what. Okay, next. Rest, people recognize. Hyphae, what are hyphae? We're not talking bacteria, we're talking the filaments on a fungi. And we'll show you pictures of that later. Filaments on a fungi. Now remember, Neisseria gonorrhea is the only gram-negative cocci we have in lab. Think about it. We have studied mostly gram-positive organisms up to the midterm, correct? Staph, strep, Clostridium, which wasn't alive, and they gave you the one was bacillus. What do you think we're going to study after the midterm? Gram-negatives. We did have a few gram-negatives for comparison. For instance, E. coli is a gram-negative. Neisseria gonorrhea, which is a diplococci, is a gram-negative. Wait a minute. You now have 2 diplococci. You have Neisseria, and I am talking gonorrhea, actually all Neisseria, especially Neisseria gonorrhea, diplococci. You could have Diplococcus pneumoniae, which is pretty much a streptococcus pneumoniae. They're both diplococci. How do you tell them apart for diseases? One has a capsule, one doesn't. Who has the capsule? Pneumonia. Neisseria does not have a capsule. And what it attaches with, because remember, a capsule helps sticking or adhesion. It has fibrin. It has fibrin. Alright, is this making sense? I'm trying to teach you, not confuse you. Okay, we did staphylococci, we did the plates, we did strep, we did E. coli. I'm going to move to aspergillus. We're back over here. What's the better way to do this? Do you remember this? What is this? Aspergillus, penicillin, aspergillus. This is an aerial hyphae. Aerial hyphae, yes, I'll tell you the answers, and I should if I don't tell you the answers. Comes to a whole ball of what? Spores. teeny green dots are individual spores. This whole thing is a fruiting body, but the fruiting body, which is the answer I want, is called I heard somebody say it, conidiophore. Conidiophore. Conidiophore.
That's the word.
And there's the word right there. All this is on path. All this on path. Okay, coming. That's just a closer up. You see hyphae. You see free spores. What type of life form? Bacterial, mold, yeast, protozoan, algae, mold, filamentous. Okay? That's even a bigger close-up of the head of the fruiting body called the conidiophore. I'm going to move to another slide. And I'll look at the light stuff in a minute, but it's a little bit hard to see in the light in the next slide. These wide open areas are for air. What are they? Alveoli. What is this a slice of? Lung. Okay? Do you see all these filaments rising up? And they're giving off little teeny pink balls. One here, one here, one here, one here. Filaments coming up. Look at this. That looks like this. It's a skeletal hand coming up. It's not aspergillus, it's what? Penicillin. This is a penicillin respiratory infection. What are the small balls? They are what structure? Spores. Okay? This is again the same thing again. So you have aerial hyphae. You have a little bit showing the fingers. I'll show you up sideways fingers. These are like fingers that are like this. The fingers would hold the spores. They've been cut off a little bit. It's the best pictures we have. This is completely upside down. Hyphae, cut off the tips, but you still have the conidiophore. In this case, the conidiophore is from here where the spores would be, down to the fingers, down to where that aerial hyphae rises out. Now the rest of the hyphae are where? Where are most of the hyphae? They're either growing in your foot, or in the ground, or they're inside the cheese. They're subterranean, right? The rest of the hyphae are in the ground. Back up. You just have to get back to text. Where I did that. Microscope. Very bacterial basics. We have anaerobes, Neisseria. Aspergillus. Bacillus anthracis. Remember, he looks like chains for us. Don't forget the most recent labs that you did. What were the most recent labs you did? People tend to forget them. You did Corynebacterium, diphtheriae. Looks like clubs. And what are your arrangements? Diploid, strep, staphylococcus. What are the other arrangements? Palisade. What does that mean? It means side by side by side. It can be vertical. It can be diagonal. It can be horizontal. Also a what? A V for snapping division, which is Corynebacterium. A V. Chinese letters is the other one. Essentially, Corynebacterium has palisades and V's and Chinese letters. It's going to look very chaotic. What does diphtheria form in the back of my throat, which you probably won't see unless people don't backstage? That real gray, thick, leathery thing is called pseudomembrane. Pseudomembrane, not spores. Corynebacterium doesn't form spores. You have to find you a pseudomembrane. They're really nasty. body bacteria and diphtheria. And remember Listeria monocytogenes. What about him? Technically, you will see him to look like a cock's eye. He can grow in what? Milk products, meat products, but also milk products. He can increase number in a refrigerator, process the placenta, can damage a fetus. Right? He can grow in your ice cream, by the way. Grow quite well in your ice cream. Real pollutants would probably be more for something else. Streptomyces griseus. Way back at the beginning, there were slides out for you to look at, and he's a bacterial actinomycete that is filamentous. But his filaments are tiny and thin. They won't be the giant clear straws you see on a fungus. They will look like a twisted mat of thin filaments. And yes, they're probably because we're hit on the card. Streptomyces, what do you antibiotic you think he makes? Streptomyces. Okay, so you can get some of your antibiotics from this. Okay, yeast. Remember what the yeast started? Because I want to go back to one more picture. And I got to go to the board, so I think y'all can find. Back to the fungi. I'm just doing this one because it was so far long ago. I want to be sure. You need to see it. I'm not waiting for it to load this morning at a certain place. Hurry up. What is this? Yeast. This gives you a better picture. What is happening here? Budding. Daughter cell, mother cell. Eukaryote, prokaryote. I'll say prokaryote. Eukaryote. Thank you. Okay, now I'm going to switch flat out. Yeah, what's your question?
You wouldn't be able to tell the difference between the two.
The yeast and bacteria? No, sorry, let me hear you. What was your question?
The difference between the yeast, like for the brewer, or to brew things.
No, you wouldn't be able to tell the difference between that and candida.
Yeah.
The yeast we dealt with when you handle, whenever this is on the review sheet, is Saccharomyces cerevisiae. Saccharomyces cerevisiae. And you need to spell that best you can. As long as I can tell it's Saccharomyces cerevisiae, you know. And I'm going to switch to the board. I want to cover a couple things in the time I have. I want to get some time to personally ask questions that you personally want covered. And to do, we can look at the slides. We've got Borrelia, we've got Treponema, we've got slides out. There will be another review Monday to and from. And then I'll give you a chance to also do the practice ones. Okay. You come up and you see something like this. What is this? Colony. Technically it's called a colony counter, but if you know colony counter, it's fine.
What?
Colony counter of colonies. Okay.
Yeah.
Okay. Technically culture colony counter, but if you say colony counter, you're okay. The whole goal, if you have a set of plates, is to find the original number of organisms and the original sample. What came from the old milk? Well, your hammering, when you blend it up to some sort of solution, how many bacteria per meal were in the original? You first have to run a dilution series, and you do 3 or 4 plates, but you've got to find the plate, the colonies, that is between what two numbers? 30 to 300. Some people do 25 to 250. Do whoever you work for. Okay? Wherever you work, do what the institution does. I'm giving you 30 to 300. So if you see 4 plates over there, do you count all 4 plates? You don't have time. Alright? So please, I stop people from counting all 4 plates. Pick the one set of plates that you think has between 30 and 300. Okay? Then you have to back calculate and tell me the number of organisms per meal. But yes, there will be information on the question card. Let's go for this one. What if you have your original sample? Took a hamburger, blended it up, you put in a solution. You want to do a dilution series on it and see if somebody should eat that or not. You did not. Take 1 meal, placed into 9 meals. Definition of dilution is the amount added over the total volume. 1 meal is added, total volume is 9 plus 1. So the dilution for this tube is a 1 to 10. Mathematically, that is 10 to the minus 1. 10 to the minus 1. All right, there's a good chance that if you just do one dilution, you're not going to have between 30 and 300 colonies. You're trying to catch one plate that will give you a countable plate. So you'll probably do a series of these dilutions, 9 meals. Now, you have to take into account that this has to have less organisms than this one. Yes, that is a 1 to 10 dilution. But you have to take both test tubes into account, and it's multiplicative. So you go 1 over 10 times 1 over 10. Your dilution is 1 over 100, which is a 10 to the minus 2. 10 to the minus 2. Still not sure you can catch a countable place. You're going to do some more dilutions. Researchers have to outguess whatever their sample is. You add 1 meal, 9, same thing again. That's a 1 to 10. This time it says test tube, test tube, test tube. That include all of them. So 1 over 10 times 1 over 10 times 1 over 10 equal to 1 over 1,000. That's 10 to the minus 3. We did pour plates. There are other ways to do it, such as surface plating, but we did pour plates. We plated a 1 meal sample. You plate 1 meal, dilution on the plate stays the same as in the tube. Stays the same as in the tube. You have to pick your plate count. Let's say this has 540. Let's say this has 72. Let's say this has 3. Which plate would you count? 1. 72. What? Is it 72 bacteria per meal in the original sample? No. You have to multiply times the dilutions. Technically, the reciprocal, which means drop the negative sign. 72 times 10 to the second. Be sure to put bacteria per meal. I would always take off if you don't have units, because it could be chickens, it could be anything. You've got to tell me what the units are. There's 2 ways to do that. I've done it both, and all my reviews. Some people like it one way, some people like another. I know that if you put this in scientific notation, if you decrease 72 by a factor 10 to keep the same number, you've got to increase your exponent on your 10. So I know off the bat that it has to be 7.2 times 10 to the third bacteria per meal. If that bothers you, that's okay. There are other ways to do it. Multiply it out. 72, number of zeros, bacteria per meal. 1, 2, 3. Give you significant figures. 7.2 times 10 to the, how many ounces? 3. Same number, right? Same number. Now, that is the number of organisms in the original sample. And yes, it'll be perfect. Alright? Don't mess up your factor 10. Don't forget your units. And just trying to help give you some heads up. Now, remember this part. I went over the other graphs in the last reviews, and then I'm going to go over these. Give me a second to put the axis on. Usually it's going to have to be by something times 10 to the x. Maybe 10 to the third, 10 to the fourth, bacterial meal. Don't forget that part. So on this one, time. This happens to be minutes because I just happen to choose minutes. It doesn't have to be minutes. It can be hours, it can be days. All right? One person said, well, it's got to be minutes, right? And I said, no, it can be any time. Now for the next part, what am I going to ask you for this? What is the generation time? Generation time is where the population doubles, right? Well, first you have to pick what? The log phase, logarithmic exponential increase. You cannot use lag. You cannot use stationary. Then you pick two numbers, but the two numbers have to have what relationship? Well, that's the definition of generation time, right? Where the numbers double. So you have to pick two numbers that double. All right? You can pick 3 and 6. You can pick 4 and what? 8. You can pick 5 and 10. As long as you're not out of the log phase. I'm going to pick 4. Come across hit. Come straight down. Come across the hit. Meaning hit the graph. Go straight down. That's probably, yes, about 20. Yeah, something like that. 27 minutes. Is that the generation time? No. You've got to find where it doubles. So go up to the 8 from the 4. Hit. Drop down. And I just say that's about 45. 45 minutes minus 27 will give you your generation time. That's it. That's it. Other thing you might have to do, and remember this is on what type of paper? Semi-logarithmic paper. Everybody okay with this? Other thing you might have to do is this. You have graphs. You have multiple graphs. Which organism grew the fastest? Number 1, because it has the steepest rise in the slope of the log phase. Which organism grew the slowest? Number 3. If the temperatures were this, organism 1 is what type of organism? Thermophile. Organism 3 is a cyclophile. Okay? Does that make sense? 45 degrees would be thermophile, if that was it. This is something else, would be something else. 4 degrees gives you cyclophile. 37, give or take, gives you mesophile. Okay? Alright. What do you think? I want to give you some time to do some things for yourself. So I'm going to wrap it up now. One more thing I want to bring up. Do you remember what plate this was? Rodak. What is that? Replica organism plating. So I'm going to ask you that. What it means is you squished it down and it copied what organisms were where. Whatever your sample was. Copied the same organisms. Right? Right. Okay. All these plates are sealed, so you're okay. You have a test question here. Yes?
What's the Rodak again?
Rodak plate, replica organism plating. It means it copies whatever you touched it to. Good question. Everybody hear the answer? I'm going to have practice questions here and here. Please do them. One more I want you to try. That you're going to apply to calculate media. Practice reading on this bottle the grams per liter that you're going to need for that ratio part of your calculation for how to make media for a class. 1 liter is how many milliliters? 1,000. Don't put down 37 to 1 because that's 1 liter. It's got to be what? Milliliters. So practice, because it is in fine print, and it won't be as much of a concern if you practice looking at it now. This is not going to be on the test. It's just an example.
Why not?
Okay? Because that is simple. It's really done now again. Okay? slides, both places to look at. You have plates to look at, 2 practice questions. Look at your notes, ask me questions, I'll answer one-on-one. Check out how to read a bottle and anything that helps.